Go, probability. So what is probability? Well, the probability is when we're talking about the likelihood of an event occurring. So how likely is it for something to occur? Is your probability. Probability is expressed as a decimal, so a number between 0 and 1. Right, so instead of saying 6 out of 10, I would have turned that into 0.6. I would just convert it into a decimal, which then helps you think about it as a percent. Well, that would be what? 60%, right? 0.6. So when you're talking about probability, you're going to express it as a number from 0 to 1. So just take whatever your fraction is that we've been talking about here, divide them out, and turn it into a decimal. And an impossible event. So if it can't happen, like if I had that 6-sided die, and I said, well, what's the probability of rolling a 10 on a 6-sided die? Is 10 in the sample space? No. So the probability would be 0. It can't happen. And the opposite of that, an event that must occur, so will always occur, would have a probability of 1. So if I rolled a 6-sided die, I said, what's the probability that I roll a number larger than 0? Well, all the numbers on the 6-sided die are larger than 0, so that would be 1. Like we said, 6 out of 6. Okay?
Is it possible to have a 7-sided die?
I don't know. I don't know if I've ever seen a 7-sided die. They have like 8-sided ones. So, some more vocabulary. I don't think there is such a thing. When we say the word trial, a trial is a systematic opportunity for an event to occur. Let's see if your calculators have this package on it. So, for example, the rolling of a number cube or a die. The book uses the word number cube for die.
Rolling of the dice.
Yeah, rolling of the dice. Or flipping a coin. Drawing a card from a deck of cards. Pulling a marble out of a bag. What would be some other trials you could do? What?
Are you supposed to say draw? Like you draw a card?
Yes.
Oh. What? As an L at the end? Because you've been saying with an L.
That's my accent from Pennsylvania. You guys say drawer weird to me.
Yeah.
Drawer?
You guys say things weird to me.
You say solid line. Wait, do you say crayons like crowns? Because that's what my dad
No, I say crayons.
Philadelphia.
I say crayons.
Solid.
Crayons. That's just my
Yeah, or wait, say
my accent.
Say downtown.
Downtown?
Is it, well, I have a cousin and her mom says downtown.
All right. So if you quickly look on your calculators, if you have them, when you do a bunch of trials, you are creating something that is called an experiment.
It's not even turning on.
So did you see how it says escape right here?
Oh, yeah.
So you hit the y equals.
Okay.
Then, yeah. So when you're doing a bunch of trials, that's called an experiment that you're creating. So experiment is one or more trials. So an experiment could be rolling a number cube 10 times, rolling a number cube 100 times, rolling a number cube 1,000 times. That wouldn't be very fun. But your calculator, you can set it to 1,000 trials and then hit one button and it'll bring up the data for it, which is kind of cool. Do it all at once. Okay, so when we're doing experiments and trials, that gets us to what experimental probability is. We already talked about sample space. We don't need to do that. So experimental probability. is approximated by performing trials and recording the ratio of the number of occurrences of the event to the number of trials. Okay, so on Monday we're going to come in and we're going to compare. We won't have time to do it today, but we'll come in and we'll compare. We'll create an experiment. We'll do the experimental probability of something, and then we'll do what's called the theoretical probability of it and see how they compare. Which is kind of a neat activity to do. See how close you can get them to come. So for your homework for tonight, you're going to have to work through some theoretical probability problems. And when you do theoretical probability, you're going to use the following formula. Everybody okay? So theoretical probability. Is a ratio. Just like we said for experimental, but experimental you have to do your trials over the total. For theoretical probability, the notation you use is a capital P. This is standing for the probability of event A. So the probability of heads, the probability of tails, the probability of rolling a 1, the probability of rolling an even number. So your A represents whatever that event is that's occurring. So you take the number of outcomes that are going to occur in event A, and you divide it by the number of outcomes in the sample space, which is what we did up here on the board before we even started notes. We did a whole bunch of theoretical probability problems. Okay? All right, so first example. Everybody good? All right, so we've got a red disc in a container that contains, so think about a bowl. Inside the bowl, they've got 2 red discs, or whatever you want to call them, 2 coins. You've got 4 blue ones, and you've got 3 yellow ones. I reach into that bowl, pick one out. What's the probability that that one disc was red?
2 out of 9.
So we need to think about, so we're doing the probability that it is red. Well, how many total reds do you have? 2. How many total discs are in the sample space? 9, right? So it'd be 2 out of 9. Probability should be expressed as a decimal, so what does that get us? 2 out of 9. 0.22. Repeating. Did I just say 0.22? What would be the probability of getting a yellow disc? 3 out of 9, so 1/3, right? Or 0.33333. What about blue? 4 out of 9, so 0.444444. Okay? All right. Everybody's good with that? Let's do one more. We're not going to do that one. Let's do the time one. The book loves these time ones. We got Eduardo. Book loves our Eduardo. You don't have to write all this stuff down. He logs onto his email once during the time interval from 1 to 2 o'clock. So we've got from 1 to 2 o'clock, Eduardo is going to log on to his email. I want to know what's the probability that he logged on somewhere between 1:30 and 1:40. Well, how large of a time span is that? 10 minutes. How many 10 minutes are there in an hour? 6. So sometimes it helps to think about it graphically like this, or visually. if this is my whole block from 1 o'clock to 2 o'clock, and I break that up into 6 sections, so how many lines would I have to draw? 5. 1, 2, 3, 4, 5. And I have 6 blocks, right? If each of these blocks represents a 10-minute section of time, so this gets us to 110, 120, 130, 140, 150, and then 2 o'clock. That was about 50. Which section would be between 130 and 140? The 4th block over, right? This one right here. So what would be the probability? 1 out of 6. What if I change this problem from 130 to 135 and shorten the time span? So now how many sections would I need to have? How many 5-minute intervals are there? 12. So if I cut each of these in half, cut it in half, cut it in half, cut it in half. So now it would be what? 1 out of 12. Okay? All right, that's all we're going to do for today.